Now we are going to study about constant increasing and decreasing functions. Here, for the constant function, the values, all the values always getting same y value. If fx is equal to, if fx is equal to y, here all the values fx is equal to c. It should be like f2 is equal to, if it is 3, f3 is equal to 3, f4 is equal to 3, f5 is equal to 3. So for the constant function, always the y value it is same. Here the y value is c, this y value is c, and the function value is c. Okay, for the constant function, all the values are same. For the increasing function, what is written here, when the value is bigger, let's say x1 value is smaller than x2, so x2 is bigger. x2 is bigger than x1, so fx2, fx1. This value is fx2 value, this value is fx1 value. As you see, it is greater. So from left to right, when you draw your graph, if your hand is going up, function is increasing. From left to right, when you draw your graph, if your hand is going down, this is decreasing function. It should be. And we are going to understand the function is increasing or not decreasing on the graph like this. If we don't have the graph, we are going to use the formula. Here, this one. We are going to choose two values. If the function values, fx value is also greater, then function is greater than. Okay. Here, there are two examples. Y is equal to x squared minus 3x and y is equal to 1 over x squared. For this two graph, I already put the graphs of the function. Here it is. And as you see, this is quadratic function. The figure is parabola. Here, in this part, function is decreasing. From left to right, when I move my hand, I'm going down. So this function is decreasing in this part. But after this part, function is going up. Function is going up. And function is increasing here. Increasing function is going to be. Okay. If the function is increasing, how we can write then? Between this side is minus infinity, this side is plus infinity. With respect to x we are talking. Between minus infinity and 3 over 2, between minus infinity and 3 over 2, this point, function is decreasing. At this point it is decreasing, as you see. Decreasing. And between 3 over 2 and infinity, function is increasing. Okay. What about the second one? 1 over x squared. 1 over x squared graph, as you see here, firstly increasing, then decreasing. Okay. How we are going to write this one? The y value, pardon, the x value is 0. This side is minus infinity, this side is plus infinity. Okay. Between minus infinity and 0, function is increasing. And 0 to infinity, function is decreasing. Okay. Next one. Here we have constant function. It says, find the value of a and b if function is constant function. Here, if you remember, I said like this. If f2 is equal to if function is constant function, f2 is equal to 3, f3 is equal to 3, f4 is equal to 3, f5 again it's going to be 3. Why it's like that? Because fx is equal to 3. So as you see, when you write here fx, if it is only constant function, it is going to take only one value, that's 3, and we don't have any x values here. We don't have any x values here. So in the question, when it is written a minus 2 x squared plus a plus b x plus 3, if this is the function, exactly we are sure about a minus 2 is equal to 0, a plus b is equal to 0. There should be only constant value 3 here. So a minus 2 is equal to 0, a is equal to 2, a plus b is equal to 0, a is equal to 2 plus b is equal to 0, b is equal to minus 2. It should be, if the function is constant function, there shouldn't be any x value. A minus 2, exactly it's equal to 0, we know that one. A plus b, exactly it should be equal to 0 here. Okay, now I'm going to explain even and odd function. What is even and odd function? Here the test, there is function even odd test, I'm calling this one. If minus x is equal to fx, if f minus x is equal to fx, then function is even. If f minus x is equal to minus fx, the function is called odd function. Here there are some examples. On the examples I'm going to explain better. Here fx is equal to x cubed minus x. To understand this function is even or odd, I need to do f minus x test. F minus x test means replace in fx function f minus x. If fx is equal to x cubed, f minus x is going to be equal to minus x cubed minus x, and f minus x is equal to minus x cubed plus x. Now the form is not equal to fx. When I get minus bracket, to understand is it f minus x is equal to minus x cubed minus x, it's going to be. Why I got minus sign? Because when I substitute minus x in the function, I found these values, and these values and fx values, they are not same. So here this value is not fx. Then I am going to get minus, because it says that there will be two possibilities: if f minus x is equal to fx, or if f minus x is equal to minus fx. So I got minus bracket to see is it fx or not. So when I got minus bracket, I recognize that what is written here, x cubed minus x, is equal to fx here. So f minus x is equal to minus fx. What kind of function it is? Function is odd function. Okay, now x squared plus 2. We are going to do again f minus x test. F minus x is equal to minus x squared plus 2. F minus x is equal to x squared plus 2. Also this is fx. So f minus x is equal to fx. This means that function is even function. Here x squared minus 3x plus 1. Again I'm going to test with minus f minus x. F minus x is equal to minus x squared minus 3 times minus x plus 1. Then f minus x is equal to x squared plus 3x plus 1. This is not fx because it should be fx, it should be equal to x squared minus 3x plus 1. Is it minus fx? To see this one, I need to get minus bracket. F minus x is equal to minus x squared minus 3x minus 1. This is not also fx. This is not fx. This is also not fx. So this case is neither case. Here, as you see, the function is not odd. Also, the function is not even. So neither even nor odd. Okay. Here, from the graph, how to understand the function is even. If the function is even, here, if the function is odd. How to understand that one? The graph of even function is symmetric with respect to y-axis. Here, the graph here, when I draw the graph here, this graph, if I can select this one, I will show also here, this graph, and as you see, when I got this one, here, when I put this one here, as you see, I choose the same, I copied the same one, and I put here. As you see, we made our graph, the red one. We complete our graph. So here the left side and the right side of the y-axis, they are same. If it is like that, the function is even function. Now, again y-axis here. I'm drawing this graph, and here, when you change this one here, as you see, it is same. This one and this one, they are same. So function is even function. What about odd function? Odd function, it is symmetric with respect to origin. So first here, this part and this part, it should be same. This part and this part, it should be same with respect to origin. Normally, with respect to origin, we can say like this: we should get the symmetric 2 times. 2 times we should get the symmetric. We should fold this one here. Here also we should fold. Okay. Now complete the graph of functions, even or odd. Okay. Here, if the function is odd, it should be symmetric with respect to x-axis. How the graph is here, on this side it should be like that. Here, this part is, and this part it should be same. Then this part it's going up, so I'm going to go up, and here. Okay. Here, this is the symmetric of even graph. What about odd? Here, what is drawn here? Normally this one and this one is same, but here it should be symmetric with respect to origin. You see, it's symmetric with respect to origin. Now function is going up. If it is symmetric with respect to origin, it should go down. So the symmetric function here, symmetric function, it should be like this. Okay.